Today we're talking about recursive formulas, and you've probably never heard this term before, but they do go right along with geometric sequences and arithmetic sequences. And a recursive formula allow you to find the nth term, which is always what we're interested in, of a sequence by performing different operations, whether it's geometric like multiplying and dividing, or arithmetic like adding and subtracting, on some of the previous terms, so one or more of the preceding terms. Okay, so that's kind of what it is, and I know that's kind of a wordy definition. And definitions, again, don't mean a lot to us in math if we don't understand what's going on. So let's say I have a sequence, and I know the first term is 7. And the formula I'm using for the equation, or for the sequence, is 3 times the previous term minus 12. And I want to find the first 5 terms. So I already know what a sub 1 is. That's my first term, right? And I know that that is 7. So the next part of this really is to find a sub 2. And I know a sub 2 will be 3 times a to the n, a sub n minus 1. What does that mean? Well, n is 2 here, so that's a sub 2 minus 1, minus 12. And we know 2 minus 1 is 1, so that's really a sub 1. And remember, they told us what a sub 1 was. That was 7. So I'm going to plug that in. So 3 times 7 is 21. Minus 12 gives us 9. So after we found a sub 2, it becomes much easier to find a sub 3, because that's 3 times a sub 3 minus 1, minus 12. 3 minus 1 is 2, so it's 3 times a sub 2, minus 12. So I'm going to plug in that previous term, which was 9. 3 times 9 is 27. 27 minus 12 gives us 15. And I'm going to repeat this process for a sub 4. So I'll do 3 times a sub 4 minus 1 minus 12. 4 minus 1 is 3, so that's really a sub 3. And remember, a sub 3 was 15. It's what I just got. 3 times 15 is 45. Minus 12 would give me 33. So that's a sub 4. And I use a sub 4 to do a sub 5. So go ahead and, using a sub 4, figure out what a sub 5 will be. Good, you should have gotten 87. Okay, so that's one neat thing we can do with recursive formulas. If they give us what the first term is and what formula we need to use, which is what they gave us in the beginning. But there's so much more we can do with recursive formulas. In fact, we can take a sequence that we're starting with and write a formula. So we can take a sequence. Let's say we're starting with 17, 13, 9, 5. First of all, we need to identify, is this a arithmetic sequence, a geometric sequence, or neither? Good, if we're looking at it, to go from 17 to 13 and 13 to 9 and 9 to 5, I'm subtracting 4 each time, which makes this arithmetic. Okay, so if I'm looking at an arithmetic sequence and I want to write a recursive formula for it, I'm going to say a sub n equals a sub n minus 1 plus d. Okay, where d is our common difference. So if I wanted to use this sequence I have as my recursive formula, it would be really easy because all I'm going to do is I'm going to say a sub n is equal to a sub n minus 1 plus my common difference, which we found was negative 4. And my a sub 1 term is 17. Okay, you don't need to include a sub 2 or a sub 3 or a sub 4 or whatever. You just need your a sub n thing, which only really you just need to solve for your common difference, and you need that a sub 1 term that we start with. Okay, so this would, if I was asked to write a formula for this sequence, this would be my answer, and I do need both parts. So that's an arithmetic sequence. What if I have 624, 96, 384, and so on? What kind of sequence is that? Arithmetic, geometric, or neither? Good, this one is geometric. And I'm multiplying by 4 each time. If I'm using an arithmetic sequence, or a geometric sequence, I'm going to write an equation with a sub n equal to r, which remember is that common ratio, times a sub n minus 1. So here, if I wanted to write a geometric recursive formula, the first part of it would be the a sub n equals my common ratio, which was 4, times a sub n minus 1, and then I need to include what my a sub 1 term is, which is 6. So that would be my answer here. Okay, so if you think back to that first example, where I had 3 times a sub n minus 1 minus 12, this is both geometric and arithmetic. The multiplying by 3, that's my geometric part, and then the minus 12 is my arithmetic part. Okay, so it is possible to be both. When that happens, or whether or not that happens, really, because it's either way, we can use recursive formulas, but we can also use explicit formulas, and we'll kind of look at the difference. Okay, so let's say I start with this recursive formula, which is a sub n equals a sub n minus 1 plus 10, and we know the a sub 1 term is 25. Well, we can see this is what kind of sequence? Good, it's arithmetic, because I have that plus 10. And this is my recursive formula. An explicit formula doesn't have this a sub n minus 1 term, where it relies on the previous term kind of thing. An explicit formula means I can find any term regardless of whether or not I know the previous term. So I can transform this into an explicit formula, and what I would do to get an explicit formula would be I need a sub n equal to a sub 1 plus n minus 1 times that difference. Okay? And these are all things I already have from my recursive formula, and I just need to plug in what I know. So I know that a sub 1 is 25. I don't know what n is. That's my variable, but I know that common difference was 10. Now that's great, but it would be better if I could simplify this in any ways I can. So the first thing I know I can do is I can distribute. So I have 25 plus 10n minus 10. Then I see I have some like terms I can combine. 25 minus 10 is 15, so I'm left with 10n plus 15. And that will work for any a sub n term. Thanks for watching.